Hi guys, so let's start this conversation. All right, hi everybody back. Sorry, I just setting up my table. Anyway, so this is what we're doing right now. How you all? Mm-hmm. Okay. What is subjective though, Saad? I didn't ask. I didn't remember that what you meant. Okay. Anyway, so shall we start? We were doing rates of reactions. Can you guys all hear me? Oh, I forgot to do one more thing. Oops, sorry. Last time I did this mistake. Okay. So, yeah, well, but the problem is I record the class on both platforms, my iPad and Zoom and on YouTube. So, OCD about that. Yeah. And it has crashed. Why does it crash? This happens. So my screen crashed. The screen to the iPad. Okay, so lucky the exams are cancelled. It's a matter of perspective. Yes, it is. Thank you for that. Yes. Yes, that's right. They might get that. All right. So you see my screen now? Back in action. Do you all see it? Okay. So all right. So let's start. ठीक है? So in the last class, we were discussing, it was the first lesson on rates of reactions. Now, I want to be discussing all the factors that help our reactants react faster. And the basic principle by which these factors affect rate are either they're going to make the collisions more frequent, like we discussed last time, or some of these are going to have just a greater proportion of successful collisions. So one of these two ways is in which you are going to have a faster rate of reaction. Now, I'm going to explicitly lay out all the factors for now in just once. So the factor number one we saw, and I'll mention it again, is concentration of solutions. Factor number two is pressure of gases, if your reactants are gases. Okay. Factor number three is surface area of particles. Okay. And pressure factor number four is what you call it. Number four is temperature. And number five is what you call it, catalysts. These are five factors that affect either greater collisions or more greater proportion of successful collisions. That's what we have so far. All right, so everybody up to speed so far? Can I continue? I don't think this was any problem here. Delaver, I would assume so. I'm not sure. It's a public holiday in Pakistan. I have to ask what's his name? Abul, okay? He takes a class tomorrow. Yeah, for those of you sitting online, this is for O levels. This is a class only for O levels. Yeah, I can answer everybody else's question right now. All right, ठीक है. Moving along. Okay. Now, so the first thing we're going to talk about is concentration. So what you need to know, and I believe we went over this last time, and the idea is, how does concentration affect rate? What is concentration? Concentration in a very rough measure is number of moles or molecules per unit volume. So in the same volume, if you have more particles, you're going to have more collisions. All right. And one way to think of that is, if you can think about, if you ever been to one of those Dodgem cars kind of thing they say in fairs and all those, If you ever been to a fun fair or one of those things that they have, you know, amusement parks, and they have those dodgem cars. Now, it's only fun if many people are riding those dodgem cars. If there's only 2 or 3 people riding the dodgem cars, you get hit very infrequently. But if you have a very crowded dodgem car section, you're going to get bumped more often. And that's the principle that is applied to, you call it, concentration. That's the same principle. Here you could see this is a lower concentration of dodgem cars. Here is a higher concentration of dodgem cars. So more collisions in the time that you play this game. Or if you get to be there for 2 minutes, you're going to get more bumping. Sometimes there's so many people, it's not even fun because you keep getting bumped and there's never really a ride. So you want, and so in the real world, this is exactly what happens when you have solutions with different concentrations. The greater the concentration, the more the reaction that will take place. I even showed you guys last time, I remember, the idea of when acid and calcium carbonate reacted. So it's a recap from that. We did that last time. So you need to understand that, very simply, mathematically speaking, the rate of a reaction is proportional to the concentration of reactant. That's important. Or as the concentration increases, rate of reaction increases. What does it mean? Well, remember, we'll also talk about how we can measure the rate of reaction. That's the last of the 3 things you have to do. First was collision theory. The second is the factors affecting the rate. And third is, how do you even measure it? How do you know it's increasing visibly? How can I, as a human being, see the rate increasing? Well, in some cases, the rates are very obvious. When you have bubbles of gas being made and you see more bubbles, less bubbles, the reaction is faster and slower. That kind of stuff, right? So we'll talk about all of that stuff. How do you measure rate? But right now, we're just basically talking about this. Yes. So, yes, Saad, you're absolutely right. If there are more particles, there's more collisions per second. You don't say more collisions, you say greater frequency of collision. We are not concerned about total collisions. Remember, rate as an idea is something happening per second or per minute. So we want more collisions per minute. And if there are more collisions per minute, the total effective collision also increases. Therefore, the rate of reaction increases. Yes. And the same applies to, we had discussed this last time, for gases. So for gases, remember one thing, and they'll teach you this in A levels also. For gases, the pressure of a gas is equivalent to, or similar to, or you could say is proportional to the gas's concentration. So basically, if I increase pressure, just like increasing concentration increases rate, you can also increase rate by increasing pressure. Because what does pressure do? Pressure just has more bombardments. Remember what, at the molecular level, what does increasing pressure mean? It means more bombardments on the wall. And that's something that you will need to remember this for gases. Because gases ka pressure is determined by because these gas molecules are randomly moving around. And it's only when they hit the walls of the container do you generate pressure. So for gases, pressure really is, and this is something that you should remember, for gases in a container, like the gas that you are sitting right now in any room is air. We say the pressure of air at normal conditions is 1 atmosphere. Now what does that 1 atmosphere represent? It represents all the molecules of oxygen and nitrogen and all other impurities bombarding against the walls of your room and the ceiling. And if the bombardments increase, the pressure increases. And if the bombardments decrease, the pressure decreases. So bombardment along the walls is how pressure is created. So if I increase pressure, all I'm doing is I'm increasing bombardments. So by increasing pressure, I am increasing bombardments. If I am increasing bombardments, what does it do? It increases frequency of collision. And if anything can increase the frequency of collision, they will result in a faster rate of reaction. As simple as that. Yeah. Any thoughts, any questions you might want to ask right now? This be the time to ask. All clear? Everybody else? Yeah? Okay. Awesome. ठीक है. Just 1 second then. Okay, can you take a minute break? There's Azan happening right now, if you don't mind. Thank you for that. Sorry, guys. Let's continue. So, okay. All right. So, getting back here, what I was saying, and I wanted to talk about the fact that we've discussed two factors already. And these are diagrams just to represent the idea that this was basically calcium carbonate and calcium carbonate, CaCO3. And I mentioned this in the last lesson. They react to make calcium chloride, carbon dioxide, and water. And this is the gas. Yeah. So here is an example of where the concentration is lower, okay, of the acid. And here's an example of where the concentration of the acid is higher. There are more particles. So there's more likely that there are more bombardment happening on this surface. Remember, the particles have to meet. So these particles are not even reacting. It's when they come and hit the calcium carbonate is when they react. But there's a greater chance of them hitting the surface because there are more of them. Per second, there is more hitting of the calcium carbonate surfaces in higher concentration there is in lower concentration. And that's the idea that higher concentration does. Similarly, the same thing. Acid hai, pani hai, it's because it's aqueous acid. In dilute acid, which is lower concentration, there are less particles, less chance of a reaction, slower the rate of reaction. In more concentrated, now, the acid particles are here. These are these gray ones that I'm going to highlight as white. So there are only 4 of these, So there are collisions happening, but it's water molecules colliding. Here, the acid particles are greater. You know, here in this diagram, they also included water molecules because they wanted to show you that there is other molecules that can be present also. But now in this particular scenario, there is still more acid. So the more particles will result in greater frequency of collision. Therefore, more chances of successful collision, which means overall rate of the reaction will increase. And the reason why I'm talking about this more often is because this is one of those factors that gets tested quite often in A levels. No levels ATP. That how does rate and how does rate and concentration of a solution affect? In fact, so much so that it's one of the biggest things you do in A levels also. O levels and A levels both. This relationship is the one we measure the most because it's the one we can change the easiest. By removing water or by adding more of the solute. Alright? And now the third factor that we want to talk about was surface area. Now the point is that if I had the same reaction happening with, if I go back for a second, now if the same reaction that happened with the calcium carbonate solid, if the calcium carbonate was powdered, the reaction would happen faster. Now what's a good example to explain this? Now if you ever gone to a cafe to have coffee, and in many cafes you get sugar as lumps. Sorry, before I continue this, somebody asked a question. Does adding water decrease the rate? Absolutely, Saad. Adding water decreases the concentration. And therefore, it decreases the rate of reaction. Absolutely. Absolutely. Yes. Okay. So, if you ever gotten sugar as those cubes, these fancy little cubes that they now sell sugar in all these hi-fi restaurants and cafes, I find it really painful because if I have that sugar, I drop it in my coffee and I got to stir it at least 10 seconds, 15 seconds for it to dissolve because I want to dissolve the sugar. It takes time to dissolve. On the other hand, if you have powdered sugar, crushed powdered sugar in packets, now this dissolves much faster. And we've practically all seen this. I hope you've had. I guess it is. Okay, maybe it is. No, Dilawar, you get them in lumps in Karachi also. And in Turkey also. And I've seen them in lumps in Dubai also. So I'm sorry, but 3 of the places I've been to does serve sugar as lumps in those boxes. So yeah, they just find it fancy and cool. The reason why they do it in Dubai and Turkey is because that's how you have to sugar with coffee. So you actually don't dissolve it in the coffee, you have it separately as a sweeter. Yeah. Somebody's asked the question that do you think the chance of GCSEs getting cancelled this year? Well, 2 of the 3 exam boards that are international have cancelled their exams. I think it'll be really stupid for CIE not to cancel, but I can't speak for them. I thought they wouldn't have, but 2 of the exam boards have cancelled, and yeah. So, don't know, but yeah. Yeah, see, it's unfair to think about all the people who don't have access to online classes and they can't study regularly. Many people didn't have school so far, properly. They're way behind their schedule of teaching and learning. So, yeah, on the other hand, cancel exam means made up results. Okay. So, no, Farwa. So when we say small powdered sugar dissolves much faster, you might think, well, powdered sugar means smaller sugar clumps. So smaller lumps of sugar means faster rate of reaction. Is it because there's less area? No. In fact, when you powder something, you increase the surface area of contact. Actually, you increase the surface area of contact. Now, what do I mean by that? Let me show it to you. EdXL exams are cancelled, AQ exams are cancelled. I don't know where they're cancelled, but they're cancelled. I'm explaining it now. Let's look at some math. Okay, can we do that? I'll explain to you. I'm going to show you a diagram, all right? One second, pasting it here. Let me explain it. So I'm going to show you a diagram for the idea being that for the same mass of something, for the same volume of something, total volume, the smaller the particles get, the greater the overall surface area gets. And uske liye we're going to do some math, all right? So the basic idea is this, and I'm going to show this here right now, is that what is it? Yeah, is that when you imagine this is a sugar lump, and the point is that if you keep cutting it, okay, if you slice it up, you get more pieces, and if you keep cutting it, you get more pieces, and the more powdered you get, you actually are increasing surface area. And let's see if we can prove that to you guys, all right? If you allow me to, okay? It's fun math. It's basic math. Imagine this is a 3 by 3 cube, okay? Now this is the same amount of sugar, or let's say the same particle that I'm slicing it up into 3 pieces now, and then I'll do 6, but let's just talk about 3. So if one particle can be made into 3 particles, what's the total surface area here of this cube? Do you guys know how to find the total surface area? Okay. Well, find the surface area for each face, and in a cube, how many faces do you have? Right? So, well, each face is what area? So, 3 by 3 is the area of each face, right? 9. And how many faces does a cube have? Rija, that length by width by height is the volume formula. Yeah. So basically in a cube, how many sides do you have? You have 6. One front, one behind, upar, niche, left, right. So the surface area for, let's say, scenario A is what? 9 times 6. Can somebody tell me how much is 9 times 6? 54. Yeah. Now let's say the same is taken. You take a knife and you slice it 3 ways. Right here, right here. So now what you've done is you have taken this to 1:3, right? And that back is 3. So the width and the depth is 3, but the height is 1. So now for each of these blocks, for each block, what's the surface area now? For each block first. Let's talk about each block first, which is 3 by 3 by 1. So this surface is a total area of 3, and let's write it down. So this is 3, and let me use a different color for the surface area. Let's say yellow is 3, and this is also 3, and this side is also 3, and the back side is also 3, but the top is 9 and the bottom is also 9. So what's the surface area in scenario B for each of these? That's 3, 4 of the 3s and 2 of the 9s. So 9 is 18, and 18 and 12 is 30, right? 3, 3, 6, 3, 9, 3, 12, and 18 is 30. So literally one of these pieces is volume is what? This highlighted section, the surface area for this. The volume is 1/3 of this, but what's the surface area? Is 30. So what's the total surface area of these 3 particles? Total, because the total was 1 particle here only, was 54. Here I have them in 3 particles. So each particle is less, which is true. Each particle will be less, but the total is what? 90. And if you go here, if you made them into these smaller ones, it's even scarier, So you could say, well, let's say so that you had 3, you had 1, and this was 1.5 and 3. So each now is like that, 1, 1.5, 3. So each of these, this back and the front are 1.5, Then this side is 3 and 3, the back side right here also. And the top is 1.5 into 3, which is 4.5 plus 4.5. So this is only one of these 6's. Now you might say, well, why am I doing this? Because this is one of the few places we get to use math in a practical way. So I got 9, 3 plus 3 plus 3 plus 3, 9 plus 9, 18. So each of these blocks is 18. And how many blocks do you have? 6 of them. So what's 6 times 18? Anybody? Okay, let me do it. So 6 times 18 is 108, which is literally double of this. So by slicing up things, you can increase the surface area. And why does it matter? Because in a solid, the surface is where the reaction takes place. All right? In a solid, that's where the reaction takes place. The acid, if this was the acid, would have to touch the surfaces to react. So it can touch 54 units of surface area. But if it was in this form, it could touch 90 units of area. But if it's in this form, 108. And imagine if these particles become smaller and smaller and smaller and smaller, theoretically speaking, the surface area will increase and increase and increase. So for the same mass, remember, for the same mass, if you make the particle size smaller, you have more of those particles and you'll get more surface area for the same particle. Total volume remains the same. Total mass remains the same. It's just surface area increases. And that's the reason when we say powder something before mixing it, it mixes better. Because mixing is a chemical reaction anyways. So this is the proof, through mathematical proof, that if you increase if you decrease particle size, you have more smaller particles, but each particle has less surface area, but the total surface area is still more, and that increases. And so particle size reducing increases surface area, which increases the rate of reaction. I hope this makes sense. I tried explaining it to the best of my ability. Yes, this is rate. Yes, Arisha, the amount was the chapter for moles. We've done that bit. This is just rate. Yeah. Amount will be the same. The powder will be faster. My sugar will be, my tea, my coffee will be as sweet with lumps of sugar or powdered sugar. Would be as sweet. Yeah. It's just that it'll just get sweeter faster with powdered sugar. Make sense? Yes, you are right. That's what I said. Absolutely. The amount of product will remain the same. The rate will be faster. When I said as sweet, that's what it implies in the real world for the reaction to be equally fast. Equal amounts. Sorry. Faster, equal amounts. Yes. So this is about surface area. So we've seen 3 factors now. Concentration of solutions increases affects rate, pressure of gases affects rate, and now surface area of solids affects rate. And the 4th factor, that factor is called temperature. And how does that affect rate? Let me show you how does temperature affect rate. Now temperature is a bit tricky. In O levels, when kids study this, or IGCSE, the teachers don't give them both parts of the explanation, because temperature can affect both the frequency of collision and also increase the proportion of successful collisions. All right? Because when something is cold, the molecules move slower. You see the blurring here is less. The blurring means their speed is less. So when the speed is less, the bombardments are fewer. And if they are moving faster, they have more collisions. Yeah. So the idea is that as temperature increases, collision frequency or frequency of collision increases. Therefore, rate increases. Yeah? So now they're like just moving faster. So if they're moving faster, look, the number of particles is the same, but they get to move faster, meaning in the same amount of time they get to move more and hit more things. So if you move faster, you're going to bump into more things. If you move slower, you're going to bump into fewer things per second, because the idea is rate is always bombardments per second. Think of rate as being bombardments, successful collisions per second. Yeah? So far okay? Yeah? Okay. But that's not the only thing, okay? Now you see, having more collisions is not the only way to increase rate. The other is also to have enough energy to overcome activation energy. Now, between particles that have less energy and particles that have more energy, which of the two sides of particles do you think I'm more likely to find particles whose energy is greater than the energy I need? Meaning, let's say there's a minimum threshold of energy that you need. We call that activation energy. So out of the two boxes, which box will have particles that can have, there's a more chance of having more energy than activation? That's the right box, because they have more energy. Because they have more energy, there are more particles that have energy greater than activation, which means not only will collision frequency increase, but proportion of successful collisions even increases. And that's why temperature is such a beautiful factor to use, because it does both things. It makes the particles move faster, but also it increases the proportion of successful collisions. Yeah. Now the idea being that, let's say you had a reaction. I want to show you a reaction. I'm talking about a reaction between metal and acid. Why do we do these? Because they're the ones that are easy to visualize in the lab. So let's say we have metal plus acid. What metal and acid? Let's take Mg and 2HCl. Now what does it make? Okay. Mg, Cl2 and hydrogen gas. Now if I have that, now what happens when this reaction starts? Now I'll show you a diagram where on the left hand side we have acid reacting with acid reacting. Now if you were to increase the temperature here, the particles will move faster, so they collide often with magnesium. This is magnesium and the gray particles are acid, but they also have extra energy, because you see, when they move faster, it is that their kinetic energy increases. Kinetic energy is, we call it EK, energy kinetic. And if kinetic energy increases, they have more energy. So this extra energy also means that that more collisions are successful. So temperature does two things. It increases the frequency of collision, and also it increases the proportion of successful collisions. All right. So if 10% of effective collision out of 100, increasing the, somebody asked this question. So if 10% were effective collisions out of 100, increasing the temperature would give us more than double the effective collisions out of 200. Yes. If you, let's say, double the temperature, you're not just going to have, you're going to have double the collisions, but your rate will be more than doubled. So you might think, you know what, I'll double temperature, I'll double energy, double frequency, double the rate. But no, it'll be much more than double because the frequency doubled. But now even the proportion of successful collisions increased by much more. So suddenly, by doubling temperature, you might have 3 times, 4 times, 5 times the increase in rate. Hence, temperature becomes a huge, huge factor in affecting rate. That's why we use a freezer. You put your meat in a freezer and you can freeze it for 100 days. Nothing will happen because what you've done is you have changed the rate of meat decay. Decaying meat is a chemical reaction, and rate doesn't only mean to increase it, you can also decrease it. So if increasing temperature increases rate that fast, even decreasing temperature decreases rate by a huge amount. So just by going from 20 degrees or 25 degrees to 0 degrees, which is by the way only going from 298 Kelvin to 273 Kelvin. Kelvin is what matters to us. It's not even 20% change, less than 10%. But the meat, instead of getting spoiled in 3 days, because if you put it outside in the every day, the meat will get spoiled in 4 days. But in a freezer, it'll stay perfectly fine for 100, 200, even a whole year if you don't take it out. And in a refrigerator, which is just a little colder than a freezer, it'll stay fine for a week. That's it. It still goes bad in the fridge. But in a freezer, it goes really, really well. So slight changes of temperature have the ability to slow down the rate or increase the rate by large, large amounts. So temperature becomes that one factor that is the most compelling to think about when we are thinking about it. All right? Any questions? The reaction rate doubles every 10 degrees. That's why it does. So if somebody tells you that, that's why it happens. Because a 10 degree change is not doubling the temperature, but the rate doubles because it's the energy, activation energy that gets affected that much. All right? Any questions about this, guys? First of all, guys, please ask your questions in either the Q&A or address them to panelists and attendees, because some people can't read the question and I'm answering something and they can't read it, and that becomes quite rude. Seriously, I'd like for you guys to be able to share with everybody so they can all read this. I hope you can read my screen though. Okay. Yeah, we don't do mathematical relationships at all, Aisha. Ignore that. It is there. The Q&A is there, by the way. Nobody just uses it. Okay, I'll revive it. Sorry, there are people on it. Sorry. So for us, they changed the Q&A. There is something else here also. Something happened. Yes. So I'll only answer the Q&A now. Thank you. So for surface area, does the proportion change? For surface area, does the proportion of successful collisions change? No. No. Remember, the proportion can only change by energy. Okay, Aisha? For surface area, you are increasing the chance of colliding with the surface by having it more surface. I'll show you that to you right now in a diagram that I was dying to use that I forgot to use. So I'll show it to you now for surface area. I don't know. I missed it in a slide. I spent time looking for these nice little diagrams, by the way. Spent lots of time looking for them. All right, great, awesome. Okay. So we're studying the factor concentration, the other factors will be constant. Yes, so when we study one factor, generally we keep the others constant. May some, do they stop moving at all? They effectively stop moving. Yes. Basically what that means is that there is no particle whose energy is greater than activation. So they're moving, but you need, every particle needs activation energy. So in a freezer, no protein molecule has energy greater than activation. All right? Well, depending on the freezer temperature, but I would guess if the free food didn't mess up for 1 month or 5 months, maybe very small. I'm just guessing. It looks like it's not, because I've known people to freeze meat for 6 months and have it, and nothing happens to it. I know those crazy people who come to Karachi, freeze nihari, take it with them to America, and have it after 6 months. Have you heard those idiots? They exist. Yes, they freeze nihari and take it with them. So if nihari can survive, that means they don't have. So no nihari molecule has energy greater than activation inside a freezer, basically. Hey, I also like nihari. I'm not gonna freeze it to take it with me to America. If I love it so much, might as well stay in Pakistan, na? Why is life so difficult when you want to freeze food to another country? Food is vanished in one day. Why would you do that? I mean, when you want to live in a country, you go enjoy that particular cuisine. Why would you like this two-faced? Oh, I love Pakistani food so much. You love it? Better stay in Pakistan. Get your ass back here. I don't like these people who love a country from afar. It's too easy, Hey, I love you, but I can't live with you. It's like going into marriage. Hey, I love you. Let's get married, but I ain't gonna live with you. I'm gonna live like freaking miles and miles and miles away from you. Yes, and once in a while I'll come home and I'll freeze your food and I'll take it with me. But I'll give you 2 weeks in 2 years, huh? It's a long flight, How many people do that about Pakistan? You did that about a person, they'd just kick you out of the house. Yeah. So, yeah, changing countries like changing wives or husbands. Do it fully. Don't cheat. Don't have an affair on the side. Give it fully your love. Yeah, seriously. Yeah. Sorry. Okay, there are people watching this on YouTube. There are 5 people on YouTube watching this. They must be like, what the hell is going on here? Well, this is my class, and I'm just a free loading spirit. All right. Anyways, getting back here. So now we can never forget the Nihari example, right? Yeah. I always love to think about things like that, because honestly speaking, that's the most practical use of chemistry I've had in my life. How to make sure food doesn't get spoiled, how to, mix my sugar faster, that kind of stuff, It comes in handy when you want to make ruah afza, or maybe, those lemon drinks in Ramzan. And, you don't put the ice first and then shake the sugar. It doesn't dissolve. It takes too long. So what you do? I warm up some of the water. I literally take hot water in a small glass. First, mix the sugar, in the solid sugar. It dissolves. Then add cold water and then ice cubes. And I've got my lemon drink very fast. And I see people shaking away, stirring in a freaking cold drink. I'm like, what is wrong with you people? Yeah. Even when they want to make cold coffee through espresso, they first have to make the hot espresso, because only hot water can extract all the coffee out of beans. Then they make it iced. No, I actually put half a cup of water on a electric kettle. It boils, pour it in a glass, add sugar, as much sugar as I want. I stir it, it dissolves, then put that hot water into a jug and then layer it up with 2 liters of cold water and put ice. 2-3 cubes of ice will make that cold again, back to normal. I don't heat the lemon water. Yes, you have exams in Ramadan, Rasad. So it happens every 10-12 years or whatever. No, not 10-12 years, what I'm talking about. It happens though. I'll tell you how long it happens. It happens every 30 years. Yeah. No, what am I saying? It does happen often though. Yeah, it happens every 36. Exactly. 36 or, 33 years. Yeah. Okay, moving on. Where was I? So what I was saying was that temperature does both. Changes the energy levels, so proportions of collisions, successful collision changes, and also the total frequency of collision changes. If you're confused about how the surface area behaves, this is a diagram that I forgot to give earlier, so I'm putting it here now. So look at all these blue particles hitting the red particles. Okay. Now, obviously, this is red particles because I've taken this from a book where these were the red particles and I've inverted the color so they look blue. But forget, this is blue particles. So blue particles can hit the outer layer of the green particles. No, the pink particles. Yeah. And there's some collisions, but not the center. Now you break it into chunks, and a lot of these particles can now hit the center. So a lot of number of the same green particle, the same pink particles, and they're running pink particles. So what basically creating smaller particle size does is it increases the frequency of the collisions we care about, the collisions between the two different reactants. Again, not every single collision between the reactant is successful. Only the ones that have energy greater than activation is successful. So by breaking it up, all I did was I increased the frequency of not collision, but increase the frequency of collision between the reactants. And then if I were to heat this up, then more of these collisions will become successful also. So yeah. Anyways, that's that. So that's the fourth factor. Yeah. Well, coffee is my favorite drink in the world. It is. I had 3 cups today. I take a painstaking approach to finding roasteries, and now there are good roasteries in Pakistan too. So somewhere up north, I find them and then deliver it to my house, and there's some amazing fresh roasted beans. Oh man, coffee is beautiful. All right, moving on, guys. The last factor. We have one more factor left. Can I talk about that? I also need to end this class 5 minutes early because on Thursdays I have to end this 5 minutes early. I was actually from 5 to 5:50, then it became 5 to 6, then it became 6 to 7. It should be 6 to 6:50. I've got to take a next class and I need to end this class and set up the next class before I take it. So anyways, let me give you a yes. Oh, Farwa, oh, you are a genius. You are a genius. The last factor that affects rate is catalysts. And what do catalysts do? Very simply, they lower activation energy needed. So now remember, there are 2 ways to increase the proportion of successful collisions. How? So if I want to increase the proportion of successful collisions, I can either give them more energy, or I lower the energy requirement. It's like kids passing an exam. I can have more kids passing an exam if I give them all more marks, or I lower the passing mark. Giving them more energy is giving them more marks. Temperature gives them more energy. We just saw that. But the other way is just lower the energy requirement. And man has been looking for this for the longest time because this is where the money is. Catalysts save a lot of costs because giving energy is costly. Temperature creating is costly. But lowering the energy requirement is extremely efficient. And catalysts are basically types of chemical compounds or chemicals कह लें आप, that somehow through magic, obviously not magic, but the way they react, but you study that in A levels, but they react in a way to ensure that when the 2 particles collide, they require lower energy. So when the requirement becomes lower, more of your collisions can become successful collisions. All right? Yeah. So I will continue this from next class. I need to finish this one more. Okay, on catalysts, but effectively we have done most of this right now. All right, but catalysts and how to measure it is what's left. That's the third class. Catalyst does not increase energy. Catalyst does not increase frequency of collision. Catalyst only increases the proportion of successful collisions. The rest of the factors increase the frequency of collision. Temperature does both. Temperature is the only factor that basically gives them more energy, so has a greater proportion of successful collisions and has more frequent collisions. Yeah, I know that's how stupid they've designed it. You know, in the US syllabus, in the US high schools, you study the same syllabus for 4 years instead of a stupid syllabus for 2 years and a better syllabus for 2 years. So think about studying A-level chemistry in 4 years versus studying O-level chemistry in 2 years, and then A-level chemistry in 2 years. But then there's no 8 subjects and 3 subjects. In American high school, you study some subjects for 4 years, that kind of thing. So that's probably why. Anyways, I'm going to end this here. So I'm going to wrap this up right here. And in the next lesson, we will talk about this a little more, see energy profile diagram graphs for this, and then also talk about graphs and how to measure rates of reactions. All right? Okay. Thanks, guys. All right. Bye-bye. Bye, guys. Thank you. Thank you. Thank you. Awesome class. Awesome class. Loved it. Yeah. 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 All right. All right. All right. All right.